All right, let's talk about a piece of tech that's basically the secret engine behind the entire AI revolution, vector databases. If you've ever typed something into a search bar and felt completely misunderstood, well, you're about to find out why and how that's all about to change.
Haven't we all been there? You search for something online. You know exactly what you mean, but the results they don't get it. You weren't just looking for a word, you were looking for an idea. And that exact gap, right there, between what we say and what we actually mean, that's the problem vector databases were born to solve. For the longest time, search was all about keywords. You type car, you get pages with the word car. Super simple, but also pretty limited, right? What we actually crave is semantic search. That's a search that gets the context. It understands that automobile and vehicle are cousins to the word car. It's searching for the meaning behind the letters, not just matching them up.
Okay, so if you want to search for ideas, you need a totally different kind of database. Not one that just stores text, but one that actually understands that invisible web of connections between all the concepts that text represents. And that brings us to the hero of our story today, the vector database. What is it? At its heart, it's a database built for something called similarity search. So instead of asking, does this document have this exact word? It asks a much smarter question. How conceptually close is this document to what I'm looking for? The best way to get your head around this is with an analogy. A traditional database, it's like the index at the back of a book. It's super literal, it can only tell you the exact page where a word appears. But a vector database? Now that's like having a brilliant librarian. You can walk up and say, hey, I'm looking for a story about courage in the face of impossible odds. And that librarian will point you to books that might not even have those exact words, but they absolutely nail the idea.
And here's the thing, this brilliant librarian is unbelievably fast. For this one specific job, finding similar concepts, a vector database can be up to 1,000 times faster than trying to make a traditional database do it. We're not talking about a small improvement here. This is a total game changer. It's what makes these huge AI applications even possible.
So how in the world do they pull this off? How do you store something as fuzzy as a concept and then find it again? Let's pop the hood and see how these databases actually think. It all really boils down to four basic things. First, you upsert data. That's a mashup of update and insert. Think of it as the librarian getting a new book, reading it, and figuring out its place in the library. Then you query it. That's you asking your question. You can also update a book's info or finally delete it, just taking it off the shelves. It's the whole life cycle of an idea right there. And this whole system maps perfectly to our library analogy. The storage layer, those are the bookshelves. But the real magic, the secret sauce, is the index layer. This isn't some simple A to Z card catalog. It's a smart map that understands how all the books relate to each other. The query engine is our librarian using that map to find your answer. And the API layer, that's just the front desk where you make your request. Now, like any really cool technology, vector databases have some incredible superpowers. But using them well means you have to make some smart choices and really understand the trade-offs you're making. Filtering is a perfect example. Let's say you only want info from the year 2024. You've got two ways to go. Pre-filtering is like telling the librarian, hey, only look in the 2024 section. It's going to be really fast. Post-filtering is more like saying, search the entire library, then just bring me back the stuff from 2024. It might be a little slower, but you could get more complete or accurate results. It's that classic battle, speed versus accuracy. But what if you need both? What if you need that conceptual, idea-based search, but you also need the pinpoint precision of an exact keyword, like a product name? Well, that's where hybrid search comes in. It literally gives you the best of both worlds, combining the power of the new with the reliability of the old. So just how fast are we talking here? Let's do a quick fire round on performance, starting with pure speed. A simple query for similar concepts can come back in just 10 to 50 milliseconds. That is, quite literally, faster than you can blink.
Next up, throughput. How much traffic can it actually handle? A single server, or what we call a node, can juggle thousands of these complex conceptual queries every single second. That's the kind of power you need for real-time AI apps serving millions of people.
And the last piece is just raw scale. We're not talking about a small local library anymore. Modern vector databases are built to index and search through billions of different ideas. That's the scale you need to map out huge chunks of the internet, or a massive company's entire knowledge base. Here's another one of those key trade-offs: consistency. Most vector databases are eventually consistent. All that means is when you add a new piece of info, it might take a moment to show up in the search results. Why? Because it lets the system run way, way faster. For most AI apps, that tiny delay is totally fine, but for something critical, like a financial transaction, you'd need strong consistency, where updates are always instant.
Okay, so we've covered the what and the how, but let's zoom out and connect this to the bigger picture. Why does this matter so much, right here, right now? Well, the answer comes down to 3 letters, RAG, or Retrieval Augmented Generation. Vector databases are the engine that makes RAG work. This is how we give large language models like ChatGPT a long-term memory or let them access specific private data. You store your information in the vector database. Then, when you ask the AI a question, it does a quick semantic search to find the most relevant stuff before it even starts to write an answer. This is what turns a cool AI into a genuinely useful and knowledgeable tool. And if you're thinking about building with this tech, the good news is the ecosystem is blowing up. But choosing the right tool really matters. If you want something that's fully managed, super reliable, and just easy to use, Pinecone is a great choice. If you're an open source fan and want that powerful hybrid search baked right in, check out Weaviate. For those high-stakes apps where speed is everything, Qdrant is an absolute beast. And if you're just playing around prototyping and want to get started in minutes, Chroma is designed to be incredibly simple. So we've made the jump from searching for words to searching for meaning. The technology isn't the barrier anymore. So the real question for all of us now is, with the ability to search for pure ideas, what profound, complex, and important questions are we finally going to be able to ask? And what answers are we going to find? Thanks for tuning in.